Have you ever wondered how oil and gas deposits form beneath the Earth's surface? This fascinating question leads us into the intriguing world of geology and specifically the concepts of sources and reservoirs. These two components play a vital role in the formation of oil and gas deposits, and understanding them is key to comprehending the complex processes occurring beneath our feet. Let's start with the basics. What are sources and reservoirs? In the realm of geology, a source refers to the organic material that over millions of years under heat and pressure transforms into hydrocarbons, the main components of oil and gas. On the other hand, a reservoir is a porous and permeable rock formation where these hydrocarbons accumulate over time. It's a bit like a sponge, soaking up and holding the oil and gas that we eventually extract and use. But why is understanding these concepts so important? Well, for geology students and enthusiasts alike, grasping the role of sources and reservoirs provides a foundation for further exploration into petroleum geology. It gives us a lens through which we can investigate the Earth's history, its geological processes, and the factors that influence the existence and location of oil and gas deposits. For those interested in the oil and gas industry, knowledge of sources and reservoirs is invaluable. It aids in the search for new deposits, informs drilling strategies, and influences the decisions made in the extraction and production processes. In essence, it's a crucial piece of the puzzle in the quest for energy resources. So, as we delve deeper into this topic, we'll explore the characteristics that define a source and a reservoir. We'll look at how these two components interact and influence each other, and how their relationship impacts the formation and extraction of oil and gas. Stay tuned as we unravel the mystery of sources and reservoirs and their interplay beneath the Earth's crust. So what exactly is a source in the geological context? Well, let's delve into it. In geology, a source, or more accurately a source rock, is a rock rich in organic material which, if heated sufficiently, will generate oil or gas. Picture a dark, carbon-loaded rock, buried kilometers deep beneath the Earth's surface. Over millions of years, the heat and pressure of being buried so deep turn this organic material into hydrocarbons, the main components of oil and gas. So you can think of a source rock as a kind of geological kitchen, cooking up hydrocarbons over eons. But not just any rock can be a source. It needs specific characteristics. Firstly, it must contain enough organic matter, usually around 1% or more. This organic matter primarily comes from tiny dead plants and animals that lived in the oceans millions of years ago. Imagine that the fuel in your car started its life as microscopic ocean critters. Secondly, the rock needs to have been buried to a sufficient depth and heated to the right temperature. Not too hot, not too cold, to cook the organic matter into oil or gas. This Goldilocks zone, where conditions are just right, is usually between 1.5 to 6 kilometers below the Earth's surface. Lastly, it's not enough for the rock to generate oil or gas. It also needs to be able to expel it. This expulsion usually happens when the rock is squeezed by the pressure of being buried, forcing the oil or gas out and into surrounding rocks. So, to sum up, a source rock is a carbon-rich rock that has been buried, heated, and squeezed just right to generate and expel oil or gas. It's the starting point in the formation of hydrocarbon deposits, the raw material that gets transformed into the fuels that power our world. Now that we've understood what a source is, let's move on to the concept of a reservoir. When we say reservoir, what comes to your mind? Is it a large body of water held back by a dam? Well, in geology, the term takes on a slightly different meaning. Here, a reservoir is a subsurface rock formation that collects and stores hydrocarbons, such as oil and natural gas. So instead of a dam holding back water, think of a layer of rock trapping precious hydrocarbons beneath the Earth's surface. Reservoirs are integral to our global energy system. They're like nature's savings account, holding deposits of hydrocarbons that we can tap into when we need energy. But not all rock formations make good reservoirs. Some might be too dense, preventing the hydrocarbons from moving around. Others might be too porous, letting the hydrocarbons escape. So what characteristics make a good reservoir? Firstly, a good reservoir rock is porous. Porosity is the measure of the void spaces in a rock where fluids can reside. Imagine a sponge. It's full of tiny holes that can hold water. Similarly, a porous rock has many small spaces that can store hydrocarbons. Secondly, a good reservoir rock has high permeability. Permeability refers to the ability of a rock to allow fluids to pass through it. It's like a highway system for hydrocarbons, allowing them to flow through the rock and eventually to the surface where we can extract them. Thirdly, an effective reservoir needs a cap rock or seal. This is a layer of impermeable rock that sits above the reservoir, preventing the hydrocarbons from escaping to the surface. Without a good seal, all the oil and gas could simply seep out and disappear. Lastly, the reservoir rock needs to be in a structural trap, a place where the movement of the earth has created a low spot for the hydrocarbons to collect. So there we have it. A reservoir is a porous and permeable rock formation with a good seal that traps and stores hydrocarbons. With a clear understanding of what a source and a reservoir are, we can now delve into how these two are related. How does a source and a reservoir work together to form oil and gas deposits? This is a question that's been sparking curiosity for years. Well, to answer this, let's delve into the fascinating relationship between a source and a reservoir. In the grand scheme of oil and gas formation, a source and a reservoir are like dance partners. They have distinct roles but must work in harmony to create something beautiful. In this case, the precious hydrocarbons we depend on. Firstly, we have the source rock. This is where the magic begins. The source rock is typically made up of organic material which over millions of years and under the right conditions of heat and pressure transforms into oil and gas. This process is known as maturation. But what happens next? How do these hydrocarbons move from the source rock to a place where they can be extracted? This is where our second dance partner, the reservoir rock, comes into play. The reservoir rock, often sandstone or limestone, has the perfect characteristics to store these hydrocarbons. It's porous, meaning it has tiny spaces or pores where fluids can be stored, and it's permeable, allowing these fluids to flow through it. But for the hydrocarbons to move from the source to the reservoir, they need a little push. This push is provided by what geologists call a migration pathway. These are roots within the rock layers that allow the hydrocarbons to move from the source to the reservoir. Now, imagine a hot cup of coffee. As the coffee cools, it releases steam that rises upwards because it's lighter than the surrounding air. This is similar to how hydrocarbons behave. Once they're formed, they too want to rise due to their lower density compared to the surrounding rock. They follow the path of least resistance, the migration pathways, to move upwards. If all goes well, these hydrocarbons will eventually find their way into the welcoming pores of the reservoir rock. This migration process can take millions of years, and it's a delicate balance. If the conditions aren't just right, the hydrocarbons may never make it to the reservoir, but when everything aligns, the right source, the perfect reservoir, and an accessible migration pathway, we get a substantial accumulation of hydrocarbons in the reservoir rock. This is what we call an oil or gas field, ready for us to tap into. Keep in mind, though, that not all source reservoir pairs are successful. Some might lack a good migration pathway, while others may have a reservoir that's not porous or permeable enough. That's why understanding the source-reservoir relationship is so important in oil and gas exploration. As we can see, the relationship between a source and a reservoir is crucial in the formation of oil and gas deposits. It's a complex dance of geology and chemistry, millions of years in the making, but when it all comes together, it can fuel our world in extraordinary ways. Why is it important to understand the source-reservoir relationship, you may wonder? Well, the answer to this question goes far beyond the realms of pure academic curiosity. It's a matter of practical significance, particularly in the field of oil and gas exploration and extraction. First, let's contemplate the primary goal of oil and gas exploration. It's to locate and quantify hydrocarbon deposits, isn't it? But how can we achieve this goal without understanding where these hydrocarbons come from and where they end up? That's where the source-reservoir relationship comes into play. A source rock generates hydrocarbons under certain conditions. These hydrocarbons then migrate and accumulate in a reservoir rock. If we can understand this relationship, we can predict the location of potential hydrocarbon reservoirs with greater accuracy. This understanding can, in turn, reduce the financial and environmental cost associated with unsuccessful drilling attempts. Moreover, the quality and quantity of hydrocarbons in a reservoir are directly linked to its source. A rich and prolific source can feed multiple reservoirs or a single large reservoir. By understanding this relationship, we can estimate the potential yield of a reservoir. This knowledge can help companies make informed decisions about where to invest their resources and how to plan their extraction strategies. But the importance of the source-reservoir relationship isn't limited to just exploration and extraction. It also plays a crucial role in the sustainable management of hydrocarbon resources. Consider this. Each reservoir has a finite capacity and each source has a finite productive lifespan. If we extract hydrocarbons too rapidly, we risk depleting the reservoir before the source can replenish it. On the other hand, if we extract too slowly, we risk wasting the productive potential of the source. By understanding the source-reservoir relationship, we can strike a balance. We can optimize extraction rates to ensure a steady supply of hydrocarbons while minimizing the risk of reservoir depletion and source wastage. This balance is key to achieving long-term sustainability in the oil and gas industry. Furthermore, the source-reservoir relationship can also provide valuable insights into the geological history of a region. It can shed light on past climatic conditions, tectonic activities, and even the evolution of life on Earth. So you see, the source-reservoir relationship is not just an abstract concept. It's a vital tool for geologists, petroleum engineers, and environmental scientists. It's a compass that guides us in our quest for hydrocarbons. It's a lens that helps us view the Earth's past. Indeed, a sound understanding of sources and reservoirs and their relationship can be a game-changer in the field of geology. It can revolutionize the way we explore for and extract hydrocarbons. It can help us tread the fine line between exploitation and conservation, and above all, it can deepen our appreciation of the complex and dynamic nature of our planet. Let's take a moment to recap what we've learned today. We've embarked on a journey deep into the bowels of the Earth and surfaced with a greater understanding of the complex geological concepts that govern our world. We started by defining a source. A source, in geological terms, is an area or rock formation that generates and expels hydrocarbons. It's the birthplace of oil and gas, where organic matter is transformed into these valuable resources over millions of years. It's like a kitchen, cooking up hydrocarbons under intense heat and pressure. Next, we moved on to the concept of a reservoir. Contrary to what the term might suggest, it's not a storage tank, but rather a porous rock formation that holds hydrocarbons. It's the sponge soaking up the oil and gas expelled by the source. These reservoirs are like the cupboards of our kitchen analogy, storing the cooked-up hydrocarbons until they can be extracted. The relationship between a source and a reservoir is a story of migration. Hydrocarbons, once formed in the source, move upwards due to their lower density, navigating through permeable rocks until they find a suitable reservoir. It's a journey driven by natural forces from the birthplace to the storage house of hydrocarbons. But what's the importance of this relationship? Why should we care about the journey of hydrocarbons from source to reservoir? Well, understanding this relationship is fundamental to the oil and gas industry. It's the map that guides exploration efforts, helping geologists predict where valuable hydrocarbon reservoirs might be located. Without a clear understanding of this relationship, finding these resources would be like searching for a needle in a haystack. Moreover, this knowledge has implications beyond the industry. It helps us appreciate the intricate geological processes that shape our world, the slow and steady transformation of organic matter into a resource that powers our lives. It's a reminder of the delicate balance in nature, the interplay of heat, pressure, time, and migration that results in the extraction of hydrocarbons. In conclusion, the journey from source to reservoir is a fascinating tale of transformation, migration, and storage. It's a tale that highlights the importance of understanding the complex geological processes that occur beneath our feet. It's a tale that underscores the significance of the source-reservoir relationship in the exploration and extraction of hydrocarbons. The next time you fill up your car's gas tank, remember the intricate geological processes that have made it possible. Until next time, keep exploring.